noise analysis, data analysis, visual analysis, statistical application on climate and weather, and many more. He has many international and national publications in reputed journals. So today, sir, we are very happy to have you, and we want to learn some of about this R language. So we request you, sir, to start the session. Thank you.
Okay, good afternoon all. So please confirm whether I am audible properly or not.
Yes,
Sir,
sir.
you are audible.
Okay, thank you very much for the confirmation. Okay, respected principal sir and my dear Professor Dash. It would have been better if Professor Das was the first speaker, but due to some of my personal issues, I requested Suparna to make myself in the first. So I would apologize for that because I think it would have been better. Anyway, so with the due respect to Professor Das, who will be all the time to kind of guide us as well. So thanks for having me for the second time because I spoke on the same issue probably in 2020. And today we are also going to be discussing basics of R. And if in between, if you have any questions, please feel free to stop me because this is workshop. So I hope you all will be trying to grab the thing. And if somewhere you get stuck, please let me know. And I feel that since the participants are very few, so we can interact also in a meaningful way. Okay, so during the presentation, I will be switching off my video and then we'll be starting the deliberation. Thank you very much. So is it visible, my PPTs? Okay, thank you. So introduction to R. So we need to understand what basically this R is. I tried to make my presentation as simple as possible because I had this information that the audience could be kind of versatile and there could be students as well. So in a single sentence, we can say that R is an open source software for statistical computations. It was conceived by Ross Ihaka and Robert Gentleman from the Department of Statistics, Auckland University, New Zealand, in early 90s. Basically, it was conceived in 1991 or 92. The first release of the software happened in 1995, and first stable beta version was released in 2000. Now, what are the attractive features of this? Because we know there are ample softwares available um, uh, in the knowledge arena, but still, what are the specificities that we are considering are? Firstly, and most importantly, for people like us, where money is a big factor, it is no license problem is there. That means it's open source, so anybody can start working on this software without any kind of license issues. Because if you talk about Minitab, SPSS, and some other like SAS and so on, all are proprietary softwares, MATLAB also. and we do not have much fund for availing those. So this is one of the greatest feature I would like to highlight upon. Then we can do very complex computations with very small codes. So this is another advantage I would mention. Great community support, this is one important factor which I would trace upon, that if somebody has grabbed R as his or her computational methods, and if they got stuck somewhere, then they can immediately Google and they can get support, because it's an open source. Anybody from the any part of the world, they also can work and contribute into the R software. So that is why lots of people works on this, and we have a great community support if we get stuck somewhere while we are working. Now huge number of packages to perform specialized computations, as it was intended for statistical computations. So that is why specifically complex statistical computations, we can have I think there are more than 10,000 packages, specialized packages, where we can perform our intended works using our software. And presently it is the most used statistical software, I would say. Somebody can say that Python is also there, but Python is some sort of a general language where you can do everything. If you want to develop one application kind of thing using data analytics, then Python could be preferable. But for hardcore statistical analysis, where some specialized things to be computed, then R should be preferable. And there can be a comparison also. I don't want to linger this discussion much regarding Python and R. Everything has some pluses and minuses, but with respect to statistical computations, we should always prefer R. Now one more thing before I go to this particular thing, that how to start, that there are definitely some disadvantages also, but I would not say those are disadvantages, but some features which we should be that it can be having some memory issues. It uses maximum memories while it is in use, so that's why it is little bit slower with respect to R and MATLAB, if we compare it. And sometimes people thinks that we have to remember the codes, or simply I would say that terms, if we need to use R. Yes, this is true, and that is true for Python also. So there are some small things which we can ignore, and once somebody has boarded on R, and it will be very used to, and there should not be any problem in grabbing this. So since it's a workshop, that's why I thought we should jump on directly to how can we start working on that. So if you are new, then you can go to this URL, or you can just simply Google this R, and then it will come this website from where you can download the software and you can Windows. I have given the link for Windows machines, but it is available for Mac and Linux as well. So this is another important feature of R, that it works across the environment and across the systems. So we do not have to worry about if you are in a specific system which is not very common. And this CRAN actually stands for Comprehensive R Archive Network. So anybody can go and download this according to your machine specifications, whether it is 32-bit or 64-bit and so on. So that's how you can download it and install it like an usual software, and then you can start working. Okay, now we can start working on our kernel. We will be showing how does it look, but for better experience, people also use R Studio, which is actually GUI, graphical user interface, which makes the use of R much simpler. And actually, there are some alternatives also, like Anaconda. Also, somebody can use, where you can work both in R and Python. In fact, in R Studio also you can work with Python as well. So RStudio actually gives us some better working environment. It's basically an environment, and use of RStudio, actually RStudio, you have to have R in your machine, R installed in your machine. So R is prerequisite for working in RStudio. Okay, so we can start. Start means we can show you how does it look when you when you download RStudio and R, and then how does it look. So RStudio looks, a typical RStudio console looks like this. There are four quadrants. In the top left, it is a place where we can write the code and save it. And then in this bottom left, which is the actually R kernel I was mentioning, where when you run the code in this top left kernel, this clicking on this run button, I hope you can see this. Let me take the pointer. Yeah, so once we run the code here, we can save it using the save button, and then you can run it, and then it shows the code as well as the output here. Okay, and this top right, this panel, actually this quadrant shows you the environment. This is actually environment where you can see the recent variables and data sets you are working on. Okay, so that also there. And this particular quadrant, which is below right or bottom right, it shows the graphs. If there is any graphical output, it shows there. So in this particular space or quadrant, we don't see the graphical outputs. However, the numerical outputs are shown here. Okay, we will be showing this in hands on, so nothing to worry about on that. Now, to start with, since it's a very basic program on R, so we can start from very basics. Once you install R, then it can be used as a calculator. If you do not have any kind of programming knowledge or anything, so you can use it as a calculator also. So as I showed you here, that this kernel looks with this greater than sign here, where we can give the calculation problem, and as soon as we click on the enter or press the hit the enter button, it shows the output like this. So here I have typed 2 plus 3, and it showed the output 5. So similarly 9 by 3 3, and 3 by 2 1.5, 7 minus 5 is 5. So this is as simple as that. And as far as mathematical operations are concerned, all operations are usual like in other softwares: plus, minus, slash for division, and star for multiplication, double star for power, and so on. So this is which I already mentioned about. And in this particular right hand side, what we are mentioning is that for mathematical preferences, when we do a kind of series of computations in a single line, that the mathematical preferences also takes place as per the mathematical rule of calculations. Okay, and then it also has some built-in functions. Okay, let me tell you what are the built-in functions, and don't get confused with this term functions. Actually, in all languages, one general rule of programming is that generally programs are very big and complex, so we develop small part of it, and then we assemble through following the syntax of the language. Now this small part we generally term as functions, and those are written in such a way that those will be used afterwards. It has some particular terms in it, that is parameter, and then input, and then output, and so on. Parameters are also called argument when the value is given. So we are not going detail of that right now, but some simply you can understand that small independent codes which can be used repeatedly are called functions. Now with respect to functions, we can say there are two types of functions. One is built-in functions, and another type is user defined functions. Like this pi, pi, we have typed and entered, and we got 3 pi. 3.141593. So this is all those, I mean, I assume all of you are from mathematics background, and even if not, then everybody has done mathematics in our class 10 level. So there we know that we knew that pi is 3.141593. So this pi is a built-in function in R as pi. Okay, so the computation related to pi, how to compute this and all those things already been there. Similarly, we can have other things like absolute. ABS means it gives the uh, numerical value, not the sign. It ignores the sign. That is, in mathematics, we call it modulus, right? So ABS 2 minus 5, it should return 3, right? Because 2 minus 3 is minus 3. When we ignore the sign, it gives 3. So for computation of absolute of anything, we have to just type ABS. So this is again an built-in function. So this is the output. We'll be doing this, no problem. Round is also a built-in function which gives us the nearest rounded up value, and for this it will give 2. Similarly, for round 3 by 2 comma 2, this gives us with decimal places. So that is how much accuracy you need. It depends on your desire, and then you can get the rounded up value accordingly. Similarly, when we typed round 3 by 2 up to 3 decimal places, then also it gave 1.5 because it exactly 1.5. Similarly, round pi by 3, it returned 1, and pi by 3 comma 2, it returned 1.05, and pi by 3 actual value is 1.047. So when it rounded up to 2 decimal places, it returned 1.05, and we know how to get this rounded up if we do it manually. So that is how basically we can see that it can be used as a calculator. Now SQRT stands for getting the square root of a value. So SQRT4 is 2, right? So this is as simple as that. Similarly, SQRT for these, and okay. Now, if we put something which is undefined mathematically, then it returns one output which is called NaN. Both the n's will be in uppercase and a will be in lowercase. So NaN means not a number. So basically, it does not return undefined. So whenever you get a NaN, that means there is something which we need to pay attention to, and that is why it attaches one warning message as well. Similarly, trigonometric log algebraic function log, you can type log 2, it gives the value, and the same way we can give the base as well. If we need to give the base, that is how we can give log 2 comma base equal to 10, and then log 10 2. This is another way as well. So log 10 2, and in the previous line we gave it in a different way. So these are some small things which we can see that if we wish to use R as a calculator, how can we use the different functions which are built in. This is e power 2 and e power 1 and so on. So I think this is something which is very easy to follow, and I hope there is no question. If there are, please let me know. Now we all know that these computations normally always do not happen like arithmetic calculations we do in our school days, especially in elementary school days. But we have to define variables where we can store values and change the values as well and do the computations for many values of that particular variable. So those are actually also known as objects in R, and we generally define those as x, y, z, and so on. Now if we define a variable x, then if its value is assigned to, then we can write it like this: x equals to 2. Okay, don't take this equal to as a kind of equal to as we use in mathematics, but this you can take it as an assignment operator. So in R, the memory, there will be a box where it will name X, and in that box it will keep the value 2. It will assign the value 2. So that is how you can take it. Now once you have assigned X equal to 2, then it will not return anything, but after that if you type X and hit the enter, then it will return the value of that particular memory box, which is actually 2. The same thing can be done as below, like X and then less than and then dash and 2. This is also the same thing what equal to is doing. This is also an assignment operator. So the value 2 is assigned to the variable X. Okay, so these are two ways we can assign values. Similarly, one variable another variable Y where value 3 is assigned, and we can see that Y also returns the value 3. So this is how we can define variable in R, and values also. And one more thing here I would like to mention, probably that is there, that let's say you have assigned value 2 to X, and after some time you have assigned value 3 to the variable X. Then if you type X, then it will return the value 3. So it actually keeps the latest value. And as I was showing that arithmetic operations, like if we define a variable or object Z, and it is nothing but a sum of x and y, then we can define it like this: Z equal to X plus Y. And as we have assigned values X and Y previously, and we have defined Z as well, now if we type Z and hit enter, we should get the value 5. So that is basically the output. Okay, so we started from arithmetic calculations, and then we um, approached to algebraic or variable computations. Now similarly, x minus y, y by x, and absolute value of x minus y, and so on. Okay, so these things I think very easy to follow, and these are the values what we are getting after these computations, and we will be showing those in real time in our console. So that is basically the calculations. Okay, now as we have defined variables in R, it is not that there are only one type of variables in R, there are several types. So let us come to those. It could be scalars, that means it has only one value, scalar. And example is like x equal to 2. Here x is a scalar. Okay, just we worked on x few minutes back. There is one another type which is known as vectors. It contains more than one values. Okay, like if we have to define a variable or vector, say x, which contains age of all the first year students. Okay, we can define, if there are 20 students, we can define 20 variables, but that will make the calculations more cumbersome. So if we take one variable or object to assign all the ages of 20 students, that will be better. And actually vector does that. How to define a vector? It is like this. So y is a vector whose, so this C actually denotes that this is a vector, and it has four values: 1 2 3 4. It is not that you have to write it in that way. So 1 2 3 4 are the entries or the values of the vector, and here y is a vector. So you can clearly differentiate between these two types of variables, scalar and vector. So scalar will contain only one value, and vector will contain more than one value. It could be any finite number. Okay, now matrices. We all know matrix are a rectangular array of numbers. So as I have given the example of students ages, Now, if we are also interested not only student ages, but also how much money they spent monthly as their pocket money. Okay, so in one direction we can write the age, and another direction we can write the pocket money, and so on. So sometimes we have to take two-way variables, or a variable which has two types of values. So that is where matrix calculations are used. So matrices are actually rectangular array of numbers. It contains rows and columns where all the member of the matrix are numeric. This is why I'm mentioning this numeric. Will be discussing few minutes after when we talk about data frames. We have given an example of a matrix, like A is a matrix which has two rows and two columns, and it has elements 2 1 1 2. So if we define it like this in R, so you look the syntax of defining a matrix. So A equals to matrix, then bracket, then C. In this C, that is, we are writing the members of the matrix as a vector, and after comma we are writing n row equals to 2. That means number of row in the matrix is 2, comma n col equals to 2. That means number of columns in the matrix is 2, comma by row equals to t. What does it signify? It signifies that we have written these values row wise. That means 2 1 is the first row and 1 2 is the second row. Okay, because if you do not write by row equal to t, then by default it takes as the column. That means 2 1 as the first column and 1 2 as the second column. Okay, I assume you are following me. Now, once we define it, then if we type A and hit enter, it should return the matrix itself. So this is the matrix which we have given as input. So 1 1 member is 2, 1 2 member is 1, 2 1 member is 1, and 2 2 is 2. Okay, so that is because we have already mentioned that by row we are giving the value by row, that is 2 1 1 2. 2 1 will be the first row and 1 will be the second row. I already mentioned, and we just got the result like this. So far we have found simply variables, scalars, vectors, and matrices, right? Now there are data frame and lists as well. So what is a data frame? Actually, data frame is also a two-way um, data structure where the columns could be numeric as well as factor. What is factor? Actually, types of variable could be numeric, factor, that is character, and I mean qualitative character, and logical as well, like true and false. And there could be complex also. So that is the variable type. So variable type could be numeric, that is a variable can contain number as its value. It can contain a character like gender, male or female, or it can also contain like a category like what is the education level, primary, secondary, higher secondary, postgraduate, and so on. So there are 3 4 categories. So that is also one type of variable. And logical variables also could be there, true and false, and some variables could be complex as well. So those are the different types of variable in R. So as I mentioned, so in the matrix I said all the values of the columns will be numeric, but in data frame one column could be of category, say categorical, and the next column could be numerical. Like if we store the data of first year students, now in one column their gender, in another column their age, in another column their monthly expense as pocket money, in another column say something else. So that will be called as a data frame. Okay, so that is a data structure. And list is also another type of data structure which actually accommodates scalars, vectors, matrices, etc. Okay, so we can show that as well, which I was mentioning that. So anyway, one more thing, I just one more sentence on list. So list can contain, it is also a composite of objects or variables, where scalar could be there, vector could be there, matrices could be there, and so on, even other data frame and so on. Now, as I was mentioning, type of variables, numeric, which I already have mentioned, it could be factor, like gender, marital status, and so on. And character also, function describes the function that returns values when called for. That is also another variable type. And the nature of an object can be found by using the comment class. That means, as I mentioned, that these are the types. Now you can have a question that how to get that. How would I know that this variable nature is numeric? A very simple command is you have to type class and you have to give the name of the variable like this. So x is getting 2.3 as its assigned value. And when we type class of x, that is class and within bracket x, it returns numeric. So that is how basically we can find the nature. And here we are trying to say that here, like y has been assigned the value c, which is a function, okay, which could be a function. And here you see the c, the same value c has been put within double quote. There, this double quote actually transforms everything as a character. So z is a variable or object which is getting the assigned value c, which is written in double quote. And when we are getting the class of z, that is what is the nature of z, it returns, it is a character, means letter and so on. Similarly, nature of an object can be changed. This is also one important feature of R, that if some variable by default or somehow it has been assigned or taken as a say numeric, we can change the value as well. Okay, it's very simple. We have to type, let's say v is a variable, and we are assigning the value of x as a character. So the value of x now is being assigned as a character to the variable v. So when we are typing class v, we are getting character. Similarly, again, the nature of v can be changed as numeric. So this can be done like this. So w, we define a new variable, and we are saying that assigned as dot numeric v. So whatever nature v had, now you change it to numeric, and that's how we get the result. Okay, so these are the different classes of variables and how we can change the classes as per our need. All these things we will be getting used to with respect to the data you have. So this is all about variables. Now if we talk vector, as we have mentioned, vectors actually stores more than one values in an object, or it can be said that vector is an object with which contains more than one values. And if there is a vector x which contains 7 values, and then it can be defined like this. So x, assignment operator, and c, actually this c is letting us know that we are going to write a vector, and we are just writing some values arbitrarily chosen 2 3 4 5 6 7, and that's how we can define a vector. Now if we type just x, it should return the values of the vector. So when we type x and hit enter, it returns the values like this. So you can see earlier when we defined x equal to 2.3 and typed x, it returned only 2.3. But here when we defined x as a vector, it returned all the values in that vector. So I think you can easily understand the differences between a vector and a scalar. One can use this term as well, that is print x, and the same output will be obtained, that is 2 3 4 5 6 7 8. So we can write x and hit enter, or we can write print x. Now let us keep on talking about vectors. Now, as I said that there were 7 elements in that vector, and if there is a vector and we do not know what is the length of this, how to get that? We have to type length and name of the vector. It returns the number of elements which are there in the vector x. So we got it 7, as there were 7 values. Interestingly, if we wish to get the fifth observation of the vector x, then we have to type like this, like x, and within third bracket we have to write the location, that is fifth observation or sixth observation or first observation and so on. And if we can remember, it was 2 3 4 5 6 7 8. So the fifth observation is 6. So it is returning the fifth observation like this. Similarly, if we are interested in typing the first 4 values, not all the 7 values, that is first through fourth observation, then we can write or get those values x and within third bracket 1 colon 4. So that returns the values from the first one up to fourth. Similarly, if we are interested in fourth through seventh, sorry, third through seventh, the same thing, x within third bracket 3 colon 7. So I think you should be now getting the point that it is not very difficult or complex to get things, because see, you see there is a similarity in everything we are doing here. Now, this is another interesting thing, that a head x is a vector, and if we type head x, it returns the first 6 observations of the vector x. No matter how many observations are there, if we type head and name of the vector, it always returns first 6 observations. Even if there are 6,000 observations, then also this head command will return first 6 observations. Now you may say that, okay, I want first 2 observations. How to get that? That is also very simple. You have to type head and within bracket x comma and then n equal to or simply 2, like here what we wrote, head within bracket x comma n, which displays the first 10 observations. Like you don't want first 6 observations, you want first 10 observations, then you have to type head x comma 10. So it is as simple as that. Similarly, as we were looking for head, we can look for tail as well. The tail also returns the last 6 observations of the vector. And if we wish to get the first 5, last 5, the same way, head and tail you need to change, and other things are similar. So for that particular variable which we were talking or we were working on, it also returns the last 5 observations. You can remember it was 2 3 4 5 6 7 8. So last 5 are 8 7 6 5 and 4. Now this is again a built-in function mean x. So x is a vector. If we type mean x, it returns the minimum of the elements which are there in the vector x. Okay, so it returns 2 because it 2 was the minimum value within the values of the vector. So again, this mean is a built-in function. Built-in function means which are already they are in R, and we cannot define our own function by the name which are already existing. That means we cannot define a new function when we'll be writing. I'll be showing that how to write a function. There we cannot use the exact the name which are already there, which are there in the built-in function. That is, we cannot write a vector, a function whose name should be abs, like that. Similarly, max returns the maximum of the observations. Okay, this is not difficult to follow, and it is 8. Now this is one interesting thing which you may get little um, weird. That is, sum x equals to 2. What does it do? Now, it displays the number of times the element 2 appeared in the vector x. Like here, there were 2, 3, 4, 5, 7, 8. So 2 appeared once. If we need to know that when the data set is very long, we cannot view it, then we have to do or get things like this, that how many times this value has occurred. So we can write sum x equals to 2, and it returns the value 1. That is, the value x, the value 2 has occurred, or are there one time in the vector x. Now this is, I think, you would find very similar with respect to Excel. Sort x, it sorts the observation of x, the vector x, in increasing order. Similarly, if we wish to get the values in decreasing order, then we have to write same thing, but we have to write decreasing equal to t. T stands for true. You can write TRUE as well, and all should be in uppercase. One more thing here I would mention, and you should also keep that in mind, that R is a case sensitive language. That means if you write here TRUE where RUE are lowercase, then it will throw an error. Okay, so whatever you are writing, you always need to follow uh, the cases, that is, in which case you should write. For built-in functions, not built-in functions, for some specific logical variables or values, you should write exactly as it should be, written. So when we wish to sort the values in decreasing order, we can do like this. Okay, now this is one interesting thing, that in a vector, if one variable is a one value, rather I would say one element is a character, then it takes all the values as character. Like we are defining a vector y where all the elements are there. It's 1, 2, and then there is a character a and 3. So when we try to get the value of y, we are getting all the values within the inverted commas. That means all are characters. So this is one interesting characteristics we need to remember. And this one, this z equal to rep 1 comma 5, it creates and displays a vector z which has 5 elements, all are 1. Rep actually stands for replication. So replicate the value 1 5 times. We'll be doing all this. Okay, now arithmetic operations on vectors. So we did arithmetic operations on variables initially for values, and then variables, and then we are coming here with vectors. And let's say x is a vector which has 4 elements, 5, 6, 7, 8, and y is also a vector which is also having 4 elements, 1, 2, 3, 4. If we add them, z x plus y, what do we get? We get the component wise added value of the variables. So z has
four elements which are nothing but component wise sum of the elements. Component wise means, or I would say position wise. So these are first element of Z will be sum of first element of X and first element of Y. Second element of Z will be sum of second element of X and second element of Y, and so on. Similarly, the subtraction Z1 we did, so 5 minus 1, 4, 6 minus 2, 4, 7 minus 3, 4, 8 minus 4, 4. So it happened coincidentally, but this is how it is. Now Z2 is a variable which is nothing but multiplication of two vectors, which is giving us the corresponding, which is giving us again a vector which is nothing but multiplication of the corresponding elements. So 5 into 1, 5, 6 into 2, 12, 7 into 3, 21, and 8 into 4, 32. So I took small examples just to show the calculations, because we can also verify at our own while we are describing the thing. So that is why I took small examples. I hope you can follow these. If we need to combine two vectors, sometimes we need to, like we have the age in one vector, somebody has supplied that we have the monthly expenses in another vector, we need to add them together for working or running a regression equation. How to do that? If we need to combine two vectors x and y column wise, that is x will be in the first column, y will be in the second column, then it is just c bind, column wise bind x comma y. So z3 will be a vector which keeps the first I mean which g3 is a matrix. It will be a matrix where the first column will be x and second column will be y. So let us see what will be the output of Z3. You can see that. So Z3 C bind x comma y, it returns x in the first column and y in the second column. Similarly, row bind, that is first row will be the x value, second row will be the y values. That is also the similar kind R bind. So C bind, R bind. This is a special type of I'd say operations we can do in R, that is getting sequence. So SEQ is the function. SEQ 1.10, it displays a sequence of numbers from 1 to 10 where the interval is 1. We did not put anything between after 1 colon 10. So by default it takes the interval 1. So it knows that it has to generate values from 1 up to 10 with an interval 1. So it returns simply 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now the same thing if we change it little bit, like sequence SEQ 1 comma 5 comma 0.5, then what is the result? It returns the values like this. So 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, and 5. So it starts at 1, ends at 5, and writes the values at zero point 0.5 interval. Similarly, this one SEQ 5 to minus 5, you see this is the value. So you can see that these are going in the reverse direction. Means here you see that here we have given the starting point and ending point, and we did not give any any increment. So here the increment by default it has taken 1. So 5 and then 4, 3, 2, 1, 0, minus 1, minus 2, minus 3, minus 4, minus 5. So that is how it is. Now I would request you all not to remember or not to think these are very cumbersome, we need to remember everything, but these are some things we are showing that how things can be done, and your work should be based on your problem. Okay, so this is some sort of a general description we are mentioning here. All the time we do not need to do every operations, but these are basics, so that is why I need to mention this. Now if we talk, so we started with scalars, then vectors, and then we are coming to matrix. So matrix is a two-dimensional data set arranged in rows and columns. In R, a two-way three-order matrix is written as follows. So earlier we have showed you 2 by 2 matrix, that is 2 rows and 2 columns. Now here we are trying to see row 2, that is there will be 2 rows but 3 columns. So if you can remember how did we write in the previous situation, the same thing we are writing here. We are writing A equal to matrix, then again bracket C, and within this particular bracket we have written all the elements of the matrix. How? In row equal to 2, that is number of rows equal to 2 and number of column equal to 3, and by row true. Okay, so before we get the output, can anybody say what will be the output of this matrix, please? Can anybody please volunteer? Are we connected? I guess we are. So that is how we can make our okay. So Jita Jaisika Ghosh, she is writing 1 2 3 4 5 6. Let me see if this was the, yes, you are right, you are absolutely right. So thank you, ma'am. Monisha Paul also answered like this. Yeah, yeah, 2 rows and 3 columns. Thank you very much. Thank you very much. So that means you are following, and that's how we can feel that things are getting used. Okay, so this, so the matrix will be this one, 1 2 3, because 2 rows and 3 columns. Okay, now a power 2, it creates a matrix of order 2 by 3. Order 2 by 3 means 2 rows and 3 columns whose elements are squares of the corresponding elements of A. That is, it will be 1 4 9 16 25 and 36. So that is simply you can verify. Now let us move on. This B, we are assigning DIAG 2 comma 5, means it is a, it is, this B is going to be a diagonal matrix of order 5 where the elements will be 2. Am I right? Just I have to check maybe. Okay, when we'll be doing this, we can verify it, that what is the output. So diagonal matrix is DIAG and 2 comma 5 will be doing, and DET within bracket name of the matrix returns as the returns the determinant of the matrix. Okay, so this is how to get the determinant. Those are very simple in R, and you don't have to compute the things using calculator and all those. Just read the matrix and get the determinant if it is a square matrix and so on. Now getting inverse is bit different. Like if we need to invert the matrix B, then we have to write it like this. So we are defining C as a inverse of B, and C is nothing but C equals to solve within bracket B. So why this solve? I think many of you are from mathematics background, or all of you are from mathematics background. So when there is a system of linear equation Ax equal to B, then X is nothing but A inverse B, right? Now if this B vector is identity, then you can understand that this inverse is nothing but the solution of the system of linear equations which I just mentioned. So that is how this solved term you can remember, because this does not uh, resemble with the word inverse in any way. So sometimes we may get confused how to find the inverse of a matrix. So it is solve B, that is solve and name of the matrix. And if you type C, it returns the matrix, and then you can compute D1, that is B into C, and as well as C into B, and you can check whether it is actually inverse we are getting or not. We will be coming there, no problem. We will be showing you hands on that it works. So these are the matrix operations we can do in R very simply, and we can go to the next. Finding eigenvalues and eigenvectors of a matrix is much simpler. Just one command, and let A be a square matrix, like we already typed 1 2 3 4. Okay, you see now here I have written true the entire term TRUE in uppercase. I could have written only capital T, but we cannot write T and RUE in lowercase. No, then it will throw an error. So that is why I mentioned R is a case sensitive, and you must remember this all the time. So we have a matrix 1 2 3 4. We need to get the eigenvalues and eigenvectors of this. One simple command, that is eigen and then name of the matrix. It displays the eigenvalues and eigenvectors of the matrix. So the eigenvalues are 5.3722813 and minus 0.3722813, and vectors are like this. So this is how we can get the matrix operations done. Other commonly used R objects are like this data frame, which we statisticians use all the time. And by the way, if somebody wishes to work on data frame in Python, then they has to import one package called pandas in Python. So as I mentioned, that Python definitely is a very nice software, and it goes along with R, but in some places R wins, some places Python wins. If you are intending for computing general purposes, that is developing an app and so on, you want to develop an app which can be used through browsers and so on, then you should go for Python. But if you are more intense in statistics, then you should stick to R. So it depends on, but both are very much useful in data sciences, though there are some other softwares like Tableau, MATLAB, SAS, everything are used in for getting data analytics done. But always you first need to think about the money, and secondly, which one is much better for my particular work. So if you have a intention to perform a general purpose work, then it is Python. But one general recommendation is, nowadays people needs to learn both the languages, R and Python both. So there is no conflict, but these are some pros and cons. Okay, so data frame is a type of data structure where we can accommodate complex type of variables. Complex means complex nature, like it can be character, a variable can be numeric, a variable can be categorical, and so on. But in matrix, all the values should be number. So that is why this data frame are like if a data set contains gender, marital status, income, expenditure for a group of people. Here age and income are age, income and expenditure are quantitative. Gender and marital status are factors or qualitative. So such a data is taken as a data frame in R. And as I mentioned earlier, note that matrix contains only numeric values. A data frame can be constructed as follows. So let's say y is a vector, x is a vector of characters, z we can define as a data frame. So data dot frame x comma y, and if we type z, then we get like this. So a b c d and y is 4354. So it is, don't get confused with the c bind with vectors. Okay, it is not c bind with vectors. It will not return the data frame. It will also, in case of output of c bind also, you may get results like this, but those things are different. And other comments for accessing different variables etc of the data frame is done as like this. Like in a data frame there are five columns. Now I want to get the nature of the column named x. So then we can go like this: class of x variable of the data frame z. So a variable of a data frame can be isolated like this z and then dollar sign and name of the particular variable. You no need to worry about. I will be showing all these from an hands-on exercise. So nothing to be worried, and you can take the PPT as well so that you can practice if you need to. Otherwise, uh, it's very easy. So class of z and y, you can see this y is numeric, so we got the numeric. The class of x was factor, so we got the factor. And if we need to display a particular variable, then also z, that is data frame dollar and then name of the variable you wish to get the values of. So these are very simple things, and through practice, once we start working, these things comes automatically. List, this is also another type of data structure which I already mentioned, that it contains all other types of data structures we already mentioned, that is scalars. So here u is a scalar, b is a vector, d is a matrix diagonal, and y is a y is a data structure. It contains both, all in fact, u, v and w, that is scalar, vector and matrix. If we type y, then it returns the value like this. Okay, so u returns 1, and u returns 1, then it returns the vector, and then it returns the matrix, that is diagonal matrix of order 3. You see, earlier we wrote a diagonal matrix with elements 2, and here we are writing diag 3, means write a diagonal matrix of order 3. It automatically takes only identity matrix. So as I mentioned, here y is a list which contains a scalar u, a vector v and a matrix w. Now in any kind of programming language, we all know that control statement and loops will always be there. What are control statements? Means where we computation are done, but there is a control. Maybe we have to sum up to the number 5. So we are giving a value n from the, we are asking a value n from the user, and if n is less than or equal to 5, then we are adding the numbers up to n, and returning the result. And if n is more than 5, then we are returning the command that the value should be less than or equal to 5. Or sometimes we need to perform a particular task repeatedly, like we need to keep on adding numbers up to 100, and we are asking for the user, asking from somewhere or number generating system that you get the number one by one and stop adding once you get 100th number. That is, we need to run that addition loop up to 100 times. So these are control and loop. These type of situations are common in all programming language. In our, loops and control statements can be implemented very easily, and we are given here two examples. What are those? U is a vector which has the elements 5, 7, 8 and 9. Now here we are asking that for I in 1 up to length u, please try to follow this on line. Print ui means it should write printing ui starting from the first element and going up to length of the vector. So length of the vector is 4. So 4 times it will start, and after 4 times it will stop. The most commonly used loops. Now somebody can write, or somebody can say that why didn't we write here 4? We could have written there, because we can count that there are 4 elements in the vector u. But the thing is, in that case the code will not be general in nature. Why? Because in this particular vector there are 4 elements, but there could be 400 elements. How do you know that how many elements are there in the vector? So when you write length of u, that means you are mentioning, you keep on typing the values ui until the length of the vector. That means until the last element appears, right? So it returns, you can see it's a one line for loop. It returns the value 5 first, then 7, then 8 and then 9. You can remember earlier we have showed that x is a vector which has 1 2 3 4, which has 2 3 4 5 6 7 8 values, and then x bracket 5, it returns 6. That is, fifth observation of that vector was 5, sorry, 6. Similarly here also we are writing, we are asking to print the ith observation of the vector. So I should be starting from 1 2, it should go up to the length of the vector, because if there is no more element, then what is the point in printing the value? It cannot print then. So that is how we can print the elements of a vector individually through a for loop. Is that clear, or do you have any question? So the syntax is, we have to type for and then I in 1 colon length u, and then the entire thing will be in the bracket, and then this is the, when this condition is followed, then what it should do, print ui, and when the condition does not follow, don't do anything. Another control statement is this. So first one is for loop. One is x is a input which is 7. We are checking first, if x greater than 10, then we are asking to paste a value that is, are we connected? Can anybody please confirm me?
Yes, sir. So there is a
Okay,
question
thank
in
you.
the chat box. Yes.
Okay, actually, when I go to the slideshow mode, at that time I cannot see the chat box. That's the problem. Okay, let me go to the chat box. Okay, so Silpipal is writing 2 power 5 is 32. How it is 729? Okay, ma'am, you have rightly pointed out. That's why I already mentioned that could be wrong. As I said, those are actually copied and pasted from the R console. So maybe I have made a mistake in copying the thing. So when we will be doing the practical, you can see the actual result. Okay, so if that has been mistyped by me, that may be a mistake, and I also got stuck there, and I think it is also not correct. And that happened because I typed it or I have copied it. Maybe that time it has wrongly typed. That's all. But we will be doing the same, generating the same diagonal matrix, and we'll be seeing the determinant. It should be 32, and because I have ran it before I started the show, so that is why I also got stuck. And thank you very much for pointing out that. Thanks a lot. Now in this particular the control statement, what I was mentioning is that if x equal to, so we are going to print two messages, that we are taking an input from the user and we are going to type whether the number is more than 10 or the number is less than 10. And obviously we are going to put the input also, that what the user has given. So here x equal to 7. So if x greater than 10, then print paste. Actually paste means that will also print and paste are similar. So whatever we write within double quote, it actually copies on the output. So the number is comma and x, it will take the value 7 here. The number is, if the value is 10, let's say, or 11, then the number is 11 more than 10. So more than 10 will also be typed as it is there because it is in double quote. Else, that means when x is greater than 10, it will print this message. Else, that is when that condition does not follow, you paste this one, that is print this message, the number 7, the number is 7 less than 10. So the problem is very simple. Using our code, we are going to check whether a number is more than 10 or less than 10, and going to print the message, the number x is less than 10 or the number x is more than 10. Because when we ask somebody to put a integer between say 0 and 100 or any integer, then it will be either more than 10 or less than 10. So I can ask computer using our code to type that, examine that number whether less than 10 or greater than 10, and type the fact. So this is one example how we handle the control statement and how do we do the loop. Now functions, as I mentioned a few minutes back, functions are defined in all programming languages for performing repetitive tasks. For example, if mean is to be computed for different sets of values, then a function for computing mean is to be thought of. Like you have some values, I have some values, somebody else have some values. We all know we have to find the mean. That is sum, and then dividing that by the number of the elements or number of the, how many observations are there. Now basically we are doing the repetitive work. So if we can write a single code and everybody is going to use that one, and that is much more useful. That is what function does. So we write a general code with some general input parameter, And for a specific usage, we give the value of the parameters. Those are known as the arguments, and we get the output. That's all. So input and then computation and then the output. That is basically the function does. So though in R already these functions like mean, variance, etc. are there, but for something else, it may be required. So I have given here example of mean, but already in R mean function is there. But some other function may not be there, like mean deviation about mean. That may not be there. We have to define a function which will compute mean deviation about mean. So it is necessary to know how to develop a function subprogram in R. That is that is making things in in separately or in separate and then assemble them to make it a uh, big thing. Okay, like assembling small parts while cars are made, something like that. So here we are writing a function subprogram to find maximum of given observations. So we have to give a name. So here we are giving the name f1. Now this equal to function. This particular term always should be there. Function x. So x, here x is the parameter. Okay. Now y equal to max of x. Print the maximum of the observation is. So this particular thing is within double quote. So we are going to get this as the output, and the value will be actually this y, and return y. So actually the computation of max is happening here, though here also we are using a inbuilt function, but our task is to getting f1. So what we are doing, I am repeating, f1 is the name. This is a function of x. What it does, it computes the maximum of the values of x, and then it prints this message, the maximum of the observation is, and then return y, means it returns the maximum value. And if we type x equal to 1 to 20, and then we need to type just this one, f1 and bracket x, because x values are given, it will return this output. The maximum of the observation is 20. Isn't it nice? Because if you type here say 1 to 50 or say 2 to 500, then also it will be given f1 and then 2 to say f1 and y. So we no need to write these all these lines 1 2 3 4 5 lines at all. So this is how we can understand the utility of functions, or why do we need to have functions. Once we have defined it, nobody is going to rewrite it again. They are just need to know the name of that function. That is f1 is a function which returns the maximum of the observations of the parameters given. Okay, so that is how we can understand how does a function is defined and how we get the result. Now we are giving you another example. Here we are defining another function, namely f2. What it does, from a vector it returns maximum, minimum and sum of the values of the vector, and it returns the messages also. The maximum, minimum and sum of the observations are return y. Okay, so I have written small code so that you can, even if somebody has installed R by this time, they can immediately copy it and write it on the screen. So we are giving the vector from 1 to 15 and just typing f2x, nothing else. We are going to get the values. So 15 is the maximum value, 1 is the minimum value, and sum of all the numbers starting from 1 to 15 is 120. So you can understand that if we would have given f2 and we would have given say z equal to say 5 to 125 for example, and f2z, then it would have given the result within second, right? So if in your directory where you are working, the functions you have defined, you can call them as and when required. That is the utility of having functions, and those what we are using already like abs and then sqrt, that is square root, and all those are actually they have made it available for R because everybody uses this. But if you need to develop some functions which will be specific for your work, you have
Excuse me,
to
sir.
develop that one.
Excuse me, sir. Am I audible to you?
Yeah, yeah, sure, please go ahead.
Sir, before this, you said about the for loop one. So in that for loop, you said about that for I in one column length. So the if I run that in the R Studio, it's saying that there is an error in this in. So can you please suggest what to write?
Yeah, see, okay, let me tell you. It can happen that, as I said, in some of the codes, when I typed from the R console and copied it into the PPT, some sort of comma or space or something might have gone into. So if there is something, we can correct it. So that is not a problem. When we'll be doing the practical, we can see that. Okay.
So then what will be in that place? In place of in, is it equal to?
No, no, I think it will not be equal to. It will not be. Can you just say once more?
So if you go to the previous slide where you have said about the for loop, this
This
one,
one.
yes, yes, it's
Hmm.
written for I in one colon length of u. So there is a term in, I and in. So if
Yeah,
I
yeah,
run
in.
this statement in the Art Studio, it shows that there is an error in in.
No, no, this should not be. Okay, we'll be doing this and then we'll be getting there. Okay. So please have patience up to there. All other things are okay. Did you check or not yet?
Yes, sir. Means actually I checked for the for loop, but then there is a problem. It's showing error.
Okay, then we'll fix it. No problem. Bugs could be there, no issue. But here our objective is first to get the notion how these things happens, the syntax as well. But even if in some places if we made some mistake, we can correct it. No problem.
Okay, sir.
When you write some code, always you are going to get stuck because of some syntaxes. It is bound to happen no matter how small code you are writing, but we need to fix it.
Uh,
I'll be coming there. Okay. Is there anything else?
But sir, no error is coming. I have seen the same code. Hello.
Just a minute. So as I cannot see the names, can you just
Yes, sir. I'm Mona
okay,
Lisa. Mona
Monisha
Lisa.
Pal, Mona Lisa, sorry, I'm sorry, missing out your name. So Mona Lisa Pal is saying she has ran the code and there is no error.
Yes, sir.
And who were getting the error? Who was getting the error?
sir, I'm
Okay, Silpi. Okay, so I think in that case, Mona Lisa, what we can do is while we'll be doing the practicals, you can share your screen, and by that we can get it done. Okay,
Okay, sir.
no problem. I tried my best not to commit any error while I prepare the PPT, but sometimes still it happened because I know that 729, that determinant of that has actually is a mistake. So we need to correct that one. Okay, but see, one thing is don't get scared or don't get worried when you have a error message. So that's how we can correct ourselves coding is definitely interesting job. And if there is something wrong, we can correct it, and that's how we move on. So we were in this function, and we have defined two functions, and okay, now another function, probably computing mean of some given numbers. We are taking numbers from 2 to 20 and mean of x. So this mean of x, this will actually return the value from the inbuilt function. Okay, now we are going to define the median. Okay, so these are all coming from built-in functions. See, I have mentioned built-in functions in R. So median of x, 1 to 9 median of x, and alternative, that we are going to compute using functions. uh, Z sort x. So first we are sorting the values from 1 to 9. Then we are taking the length of x, how many values are there, that is equal to length of x, that is finds the number of observations in the data. Now median, we know that median is the middlemost value after arranging the numbers in ascending or descending order, right? Therefore median we computed. So median is equal to z, and then within bracket, this within bracket means it is the that observation. So here n equal to 9, 1 2 3 4 5 6 7 8 9, 9 observations. So 9 plus 1, 10, 10 by 2 is 5. So that is g5, that is fifth observation of the z vector will be the median. What is the z vector? It is the vector of observations after arranging them in ascending order, and this is the median. So here actually we are computing the median alternatively, not using the function. So when number of observation is even, that is when here 9, but if it is 10, then we have to take the median as the n by 2, as the arithmetic mean of n by 2th and n by 2 plus first observation. That is, যদি total observation 10টা থাকে, তাহলে ফিফথ আর সিক্সথ অবজারভেশনের অ্যারিথমেটিক মিনটা হয় মিডিয়ান, তখন মিনটা ইউনিক হয় না। সেই জন্য যখন এনটা ইভেন, তখন মিডিয়ানটা আমরা এইভাবে কম্পিউট করছি, দ্যাট ইজ ordered observation n by 2 plus n by 2 plus 1 and arithmetic average of those, because we are taking two observations and dividing it by 2 and median. So this is how we can write small codes. Computing mode, here also we are having these values. Then this fr is actually making the frequency table, fr and table of x, so simple. And then if we type fr, it returns the frequency table, and we did not show the output of the frequency table here. And we see that here 2 has the maximum frequency because 2 has occurred 1 2 3 times, and all other number like 4 3 5 6 all has happened only once. So 2 is the median mode. And finding measures of dispersion, I'm sorry, I am actually taking all the examples from statistics because I am from statistics background. Maybe because of that we have included those, but you can take these as mathematical problems. So in dispersion we find what? Range, standard deviation, variance, and all those things. So range is nothing but difference between maximum observation and minimum observation. So we have the values from 1 to 10, and we are defining range equal to max of x minus mean of x. That's how we can do range. And then mean deviation about mean. So these are the observation. M is the mean of x, and then mean deviation about mean is mean of absolute values of the observations minus its mean, right? That is sum of xi minus x bar divided by n. This is the mean deviation about mean. That's what we are computing here. And so these are some small codes which you can compute, or we can define your own problem and compute the thing. Okay, because when you can do a thing for small data set, the same code will work for large data set as well. If the uh, data set is changed, there is nothing to change. Like here I have given 1 to 10, I can give 1 to 1 lakh even, it will do the same thing. So that is the beauty of using computers, because we use machines for doing things repeatedly and doing large volume of things. Otherwise we would not have thought of machines. decimal places this one. Square root of 3 is square root of 4. Sorry. Now undefined is now returned as nan, which I already mentioned. Square root of minus 2 is nan. Log 2 and then log 2 base 10 and then log 10 e power 2 e power 1. Then variable definition x equal to 2 and typing x assigning value 2 in a different way, we are getting the value. That's what we have noted here, that equal to and less than dash both are assignment operators. Then y and getting the value of y. Z is x plus y, value of z is 2 plus 3 is 5. Z2 is x minus 5, that is x minus y, that is minus 1, that is 2 minus 3 is minus 1. Absolute of 2 minus 3 is 1. And then y by x is y is 3, 3 by 2 is 1.5. Now, as I mentioned, knowing the nature of the variable, whether numeric or character or so on. So class of x numeric, class of y function, class of c character, and then changing the nature. Now it was numeric, changing into v, that is, sorry, changing it to character, and again the again this character nature is going to change to numeric, the same thing. And defining vector, so this is x, and how we are defining vector in R. Then we are printing the values of the vector, then finding the length, that is number of elements in the vector, then x bracket 5, that is fifth element of the vector, this one. Then writing the first four values of the vector, this one. Then writing the values of third, fourth, fifth, sixth and seventh, this one. Then getting the head of the vector, first six observations, getting the head and first three observations, this one. Getting the tail, getting the tail and last three observations actually, so 6 7 8. And getting the minimum of the observations, maximum of the observation of the vector, number of times 2 has occurred here, it is one time. Then sorting the values of the vector x, sorting the value of the vector x in decreasing order. Then if one value of the vector is a character, then all values are taken as character, you see those. And then now we are operations with two vectors, so x and y are two vectors, adding those, z equal to xy plus y, so component wise additions are happening. Then z1 is x minus y, and then z2 is x cross y, that is x into y, it is the component wise multiplication. Okay, now as I showed, c bind, that is column bind, x comma y, c bind, so it writes the vector values column wise, first x and then y. Similarly the row bind, r bind, you see first the x and then y. Then coming to sequence, generating first 10 values with interval 1, and then this one generating first few values with interval zero point 0.5. You see we are getting these. Even if I change this one up to 0.3, then also you can see a different result. You see the value got changed. It could not write up to 5 because with interval zero point 0.3, 4.9 plus 0.3 becomes more than 5. So that is why it is stopping at 4.5. Now this one writing the sequence in a from large to small. Now here matrix, defining a matrix with 2 row and 3 columns. And if we change a value particular test, right, it's 8, then you see it got changed. Then a power 2 means square of the individual elements. A cross a, this is also multiplication. And then yeah, now here we came to the diagonal. You see we got a 5 or fifth order diagonal matrix of order 5 where diagonal elements are 2. Now determinant of b is 32. Yes, you are right, probably Silpi told that. Yeah, that then I need to correct the PPT, and I also was also having that doubt. Okay, let us change this one once more. Let us write here 4 and then run this one again. So here we have now all the diagonal elements 4, and determinant of this matrix will be 4 power 5. So it will be 124. 124. Okay. Now solution. This is the solution, that is the inverse. And this is C into B. Again, we can write B into C. We got the identity matrix, so the inverse is perfect. And then we are getting the eigenvalues. You see that eigenvalue is simply eigen and then name of the matrix. Oh, oops. Sorry. I made something. Okay, non-square matrix. Okay, you see, yeah, this is what you may get sometimes. See, right? Why? Because here we have defined the matrix A and then returns eigenvalues, error in eigen A, non-square matrix in eigen. Why it is non-square? It is 2 by 2. Probably no, okay. Let me tell you why it is happening. See, I did not run this cell, right? And then I am asking for uh, eigenvalues. So it is taking one A which has been defined earlier. I don't know where, but maybe somewhere. But let me do this now. Now I ran it. Now it will take A as this one. Now it will give us the result. You see, now I got the result. So like that, you may get stuck somewhere, but don't get confused. Look for the mistake you made and correct it. Okay. I hope you could follow this one. Now this one is data frame. Y is a numeric variable, X is a variable with character, and we are defining a data frame. It is data dot frame X comma Y. Okay, so this is basically how it looks like. Now, as I was saying that knowing the class of a particular variable of the data frame. So class within bracket name of the data frame dollar name of the variable. It is factor. The same way, and if we need to know the values of a different variable, we can do like this. Now list accommodates scalar and vector and diagonal matrix. So and y. So you see y. Let us take diagonal 3 with the values 3. Let us run it once more, and then you see the values got changed. It became 3 now. Okay, now probably I did not touch this one, this basic plot. I think I should not talk on this right away. Okay, one more thing I was trying to show, that is the loop. I thought that this was here, but I don't see this is here. So basics we have done. Let me find. if that is here. Whenever you cross any file in RStudio, it asks you to look for saving if you need to. Just yeah, here I think I should, yeah, here I think I find the, yeah, the functions are there. Okay, program to write elements of a vector sequentially. So u is a vector, and then for I in 1 to length u, print ui. Okay, so then see, it ran. Who was saying that it is not working? I'm sorry, I just ran it. Probably you also saw this. Didn't it run? Hello? Who was having the problem? Silpi probably, na? Mona Lisa said she ran it. She could run it. Silpi, are you there? Hello? Silpi, are you there?
Yes, sir. Yes, sir, I'm there.
Yeah, so Silpi, probably you saw. Did you see? I just ran the code and it ran.
Yes, sir.
So I think you just try afresh. It should work. What you do, you can directly take the entire code, copy it. Let me take a fresh new file, and then I am pasting it here. So this is the variable, and this is the for loop. I am running the entire code. You can run the entire code like this also. You select and then type. You see, I got the output here. This
Yes,
one.
sir, I will try again.
5, 7, 8, 9. So yeah, it happens. Nothing to worry. But the code is absolutely right that I needed to know, and that is I found. So because I also got little confused that I actually checked, and that's how I pasted. Okay, now the second one, control statement like x is 7, and then if x greater than 10, then paste this one, else paste the other one. So, okay, so you see one thing, that this particular line ends here, and then when I ran this, it is asking for plus. Plus means it is asking for more inputs. Okay, so when I gave that one, it returned the number is 7 less than 10. So I think I need to put a comma here after 7. So I think the number is 7 less than 1. So what I can do, I can number is 7. So it will come after x. So I need to give a comma here. You see what will be the change? I put the comma within the inverted, so it will be printed. It will be printed. Let me run this line of code once more. So it is 7. Yeah, the number is 7, comma, less than 10. Right? So this, now you change the number to 9 and run the same line once more. You see the number is 9 less than 10. So this is the beauty of writing a code. You just write a code, and you change the input, your result will be input. You no need to redo the thing. Once we write a code for something, we can do the thing hundreds of times without any hassle. Now writing a function subprogram to find max. So I need to run this one. Now x equal to 10, 19, and then f1x. So f1x is say x. If we write and enter it, the maximum of the observation is 90. Now you change this say f1. Now you change this f1 to say 40 or 59. So run this line, run this line. See, the maximum of the observation is 59. So the same function code is writing here, is being ran. Similarly, here also maximum, minimum, and sum. This is the functional code, right? It ran, and now I am going to get the value of for a particular value. Say x equal to, let us take here 3 to 25. Okay, 3 to 25. So that the result is different from the slide. So I got 25 is the maximum, and then minimum is 3, and 322 is the sum. That's how you can do things like this. And built-in function median, and this one. Okay, here is x, then median x. This is we can get from the R, and here we are doing it after sorting. So here it is sorts. This line is computing the number of observations. Here is the median, and the value of median is 5. When the number of observation is more, then it is this. So these are also exercises. So you can practice, since it is a workshop. You should all practice these exercises. Like this one, I can find. I'm not sure whether there were some other beforehand. I did not follow that. Compute the median after determining number of observations, even or odd. That means it is not said whether the observations is even or odd, number of observations. You have to compute, find that part. That is, checking even or odd can be a problem of programming. That is, whether it is divisible by 2 or not, that you need to check, and then you can say whether it is divisible, whether it is even or odd. Okay, so the median portion is also done. And yeah, frequency table, I did not show there the output. Now how does the frequency table looks? You see, this is how frequency table looks. So the 2 has the frequency 3, 3 has frequency 1, 4 has frequency 1, 5 has frequency 1, 6 has frequency 1. Frequency means how many times a particular value has occurred. So this is the vector 2 occurred 3 times, that is why 3. So like that, it can compute the frequency by itself as we have written the code. Now measures and dispersion we are not going to discuss anymore. Yeah, moments. So moments, it is again a function. So it has ran up to this, and then x equal to 1 to 10. Now we are computing the, once it is ran, now we can find the moment of order 4, order 2, order 3, order 1, like that. You can change anything. Say, let's say it is 4 to 10. Then you can run once more. See, the values got changed, right? So I think that's all for today. We can stop here. I think it is exactly 2 hours or little overridden. if you have any questions, you can go ahead, or we can stop here. I think I had an intention to discuss the diagrammatic representation, but I think we cannot do it because people may get exhausted. Okay, any specific comments or anything you'd like to discuss? So all of you need to